Good afternoon, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hamper Kliman. And of course, if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share to others. If you have a question, inbox me on the WhatsApp line projected on the screen. And of course, if you've got challenges, make sure that you register for personal tuitions. We have an interesting question here. They're saying using dimensional analysis, derive a possible formula for the period t of a simple pendulum assuming it depends on length L, mass m, and gravitational acceleration. Note that the actual formula ignores m but show the process. So the first thing we are going to do here, we are going to say, let me just get my pen. We are going to say solution. We have been given period t. We are going to find the dimensions of period. That's the first thing you do, which is going to be capital letter T. What are the dimensions of length? The dimensions of length is simply big letter L. What are the dimensions of mass? The dimensions of mass is simply capital letter M. This is quite an interesting question and very complex. What are the dimensions of gravitational field force or acceleration? It is simply mlt to the power negative 2 in MLT concept. If we are to depict a relationship based on the question, they are saying that the period, we derive a possible formula for the period t of a simple pendulum, assuming it depends on the length, mass, and gravitational field force. So my relationship is going to be some period is going to variate with some L. Then I'm going to introduce a power A multiplied by some B. So I'm multiplying by m, which is the mass. Then I introduce a power B multiplied by the gravitational field force. Then I'm going to introduce a power C. From here, we know that if we introduce the equal sign, then we introduce a constant here. Then this becomes L to the power A, then m to the power B, then g to the power c. We shall be using the same concept over and over again. Just make sure that you grab this simple concept. What are the dimensions of t? It's t. So I'm going to introduce a t there. Then because k doesn't have a dimension, I won't put it there. What are the dimensions of L? The dimensions of L is simply big letter L to the power A. What are the dimensions of mass? It's big letter M, and that is to the power B. What are the dimensions of G? The dimensions of G is m L t negative 2, and that is going to be to the power C. We can formulate formulas. So the first formula we are going to generate, we'll start with the L. So because we do not have L on the left hand side, we shall say L to the power 0 is going to equal to, because we are multiplying L on the right hand side, and if you are multiplying the same bases, you add the powers. So because this is L, so it's going to be L to the power A. Okay, which other L do we have? We have L here, and that is going to be L to the power L plus C. That becomes the first formula. Okay, so we can say L to the power 0 is equal to L to the power A plus C is going to be our first formula. Okay, that is going to be our first formula. Let's try to derive the second formula. The second formula is going to have an m. Because we do not have m on the left, so we're going to say m to the power 0 is equal to, So if you're multiplying same base, you add the powers. So we have m to the power b plus, okay, then this m is also contained in a c, so it will be plus c. This can be our second formula. So we can say formula 2 is going to be m to the power 0 is equal to m, then b plus c. This becomes our second equation. Okay, let's try to see how the third equation is going to be. Because we've got t, this t is to the power 1 there, and it is going to equal to, okay, so we've got a t to the power negative 2c there. It's here. So this becomes our third equation. From this equation, we can find the value of c. So this is going to be a 1 equal to negative 2c. So over negative 2 over negative 2. And of course, our c is going to equal to negative 1 over 2. Okay? Then we use the first one. So if we're using the first one, we are going to say L to the power 0 is equal to L, then A plus C. Okay? Then of course, when you reach there, what are you going to do? So it becomes very simple when you reach there. It will become very simple. The only thing that you are supposed to do is to cancel these guys, and you're going to remain the 0 equal to A plus C. What is C? C is, so we're going to have 0 is equal to A plus C was negative 1 over 2. So you're going to put negative 1 over 2 there. This implies that your A is going to equal to 1 over 2. That is a half. Okay, that is a half. Now, what happens when you reach here? Let me wrap the board. I want you to pay extra attention what is going to happen here. Let's try to solve for A for B. M to the power 0 is equal to M B plus C. What is M? If you cancel these guys, are going to have a 0 here. Then B, of course, C is a minus, so it's going to be minus negative 2. And of course, you're going to have okay, you're going to have a positive 1 over 2 there. Now, we have solved for the values of A, B, and C. So our B, in this case, is going to equal to 1 over 2. Okay, we can go back to our formula. When we go back to our formula, remember the relationship was T is equal to K LA MB then GC. We can put the powers where there is L. What was the value of A? It was positive 1 over 2. What was the value of B? It was 1 over 2. What was the value of C? The value of C, of course, was negative 1 over 2. The question is saying the actual formula ignores M. So we are going to ignore M. So it implies that if we're generating our final formula, we are only going to have L to the power 1 over 2 and G to the power negative 2. Now notice that L to the power 1 over 2 can also be written as the square root of L. And G to the power negative 1 over 2 can also be written as 1 over the square root of G. So this can also be written as K, the square root of L over the square root of G. So the final formula is going to be period is equal to K. Then remember, you can combine the square root and then you're going to have L over G. That is how you come up with the formula for period. Okay? That's how you come up with the formula for period using dimensional analysis. We can go to the second question we are going to use the same concept. These are quite interesting questions, very complex, but very easy if you understand the concept. Okay, so solution. Derive the formula for the speed v. What are the speed v of a wave? First of all, let's finish the question. Of a wave on a string under tension F with linear mass density, mass per unit length, using dimensional analysis. Assume v depends only on F and mu. Please make sure that you go on the internet. You can try to confirm if this is the formula for period. Then, of course, you can give us a subscription and a comment. Okay, so the first thing we do is to find the dimensions. What are the dimensions of velocity? It is simply LT, negative 1. It's supposed to be negative 1. Okay, supposed to be negative 1. So this is going to be negative 1. What are the dimensions of force? The dimensions of force is equal to MLT. Okay, MLT to the power negative 2. Okay, MLT to the power negative 2. Okay, that is how you find the dimensions of force. Okay, that is MLT to the power negative 2. What are the dimensions of mu? The dimensions of mu, according to the question, is they're saying it is mass per unit length. So of course we know that this is going to be mass per unit length. So it can also be written as ml to the power negative 2. Now they're saying we assume that velocity depends on F and mu. So it implies that your velocity varies with some tension force, which can be raised to the power A, like I did in the first question, and some mu raised to the power B. And of course, if we introduce the equal sign, then we have a constant K, F to the power A, then mu to the power B. What are the dimensions of velocity? It is LT neg 1. Of course, we are now into dimensions, so we won't put the K constant. Dimensions of force, it is MLT negative 2. Okay, raised to the power A. What are the dimensions of mu? It is ML neg 1 to the power B. Let's try to derive some formulas. We are going to start with M. If we are using M, there is no M on the right hand side. So if we're using M, then this is going to be M to the power 0 is equal to, then because we've got M on the right hand side, so remember if you're multiplying the same base, you add the powers. So this is going to be M to the power A there, plus this is going to be M to the power B. And that becomes our formula 1. The second formula, because we've got L there, we can use L. So it's going to be L to the power 1 because we've got L to the power 1, which is here on the left hand side. It is going to equal to, this is going to be L to the power A because we are multiplying L. Remember, you are multiplying the same base, you add the powers. So this is going to be L to the power A plus, but because it's a minus, there's a negative 1, so it's going to be a minus B. That becomes equation 2. Okay, we can now use T. If we are using T, then this is going to be T to the power negative 1 is going to equal to, then that is going to be T to the power negative 2A. That becomes our equation 3. Let's try to use the simplest equation, which is equation 3. So T to the power negative 1 is going to equal to t to the power negative 2a. If we cancel the bases, we are going to have negative 1 is equal to negative 2a over negative 2 over negative 2. If you cancel both sides, you are going to have a equal to 1 over 2. Let's try to find the value of b. So we can use the first or the second equation. Okay, let's use the first equation. Okay, so if we're using the first equation, m to the power 0 is equal to ma plus b. We can cancel the bases. We're going to have a 0 equal to a plus b. Then, of course, we know that our a is 1 over 2 plus a b, implying that our b is going to be negative 1 over 2. We go back to our equation, which happens to be this one. So we're going to say v is equal to, okay, so in this case, we won't include the constant k. So, of course, we know that our force is equal to the power a. So what is power a? Power a, we found a to be 1 over 2. Okay, this is multiplied by mu, which we found to the equal to the power, this is b was equal to the power negative 1 over 2. I mentioned in the first question that f to the power f to the power 1 over 2 is just the same as the square root of f over, this is mu to the power negative 1 over 2. So that is just the same as like that. If you combine the formula, you are going to get this formula f over mu. Try to find how the velocity of the speed of a wave on a string. If you find this formula, give us a subscription and a comment, and that is how you establish that particular question. Okay, we have an interesting question. They're saying the kinetic energy Ke has dimensions kg m to the power 2, and it can be written in terms of momentum p and mass m, like that. They're saying determine the proper units for momentum. We determine the proper units for momentum. That's the first question. To determine the proper units for momentum, we have been given the formula Ke is equal to p to the power 2 over 2m. We can cross multiply. We are going to get p to the power 2 is equal to Ke multiplied by 2m. Of course, you square root this side, you square root that side. Your momentum p is going to equal to root of, okay, remember that in this case, our 2 is dimensionless. Okay, our 2 is dimensionless, so we are just going to have Ke multiplying by m. Then we can get the dimensions. What are the units of Ke? We have been told that it is actually kg. Okay, kg multiplied by mass to the power 2, then s to the power negative 2. Then what are the units of mass? It is kg. So if you multiply what is inside, you're going to get something like this. Kg to the power 2, because this kg and that kg will multiply, then m to the power, then of course you're going to have the m to the power 2 there, then s to the power negative 2, like that. Okay, when you reach there, you are going to cancel. So this square root is cancelling with this 2. This same square root is cancelling with this 2 for m. This same square root is cancelling with this 2 for s. So you're going to have a negative 1 there. Henceforth, if you are to find the units of momentum, they will be kg multiplied by m multiplied by s to the power negative 1. Okay? If you are to insert them in dimensional analysis, you discover that for momentum, because these are kgs, they come from their dimensions of big letter M for mass, and because this is meter, it comes from its dimension L, and because this is time, it comes from its dimension T. If you try to find the dimensions of momentum, you'll find that those are the dimensions. Henceforth, these are the correct units of momentum. Okay, those are the correct units of momentum. Make sure that you are following up the concepts. Now, we go to the second question, which is B. Given the units of force, write a simple equation relating a constant force, okay, a constant force, F exerted on an object an interval of time t during which the force is applied and the resulting momentum of the object P. So they want you to derive a relationship that is going to be between force, time, and the momentum. Force, time, and the momentum. All right. So it will actually be very simple. It will actually be very simple. So the first thing that we are going to do, we are going to, okay, let me say B. The same we establish a relationship that is going to be between force, momentum, and time. So our force, we are using the same concept. Our force is going to variate with some momentum multiplied by, don't forget to raise to a certain power, multiplied by some time, t, raised to the power b. Now, what are the dimensions of force? The dimensions of force is simply m, l, t, okay, to the power negative 2. If we put it in unit form, you can actually put it in the unit form from dimensional analysis, meaning the units for force, where there is m, I'm going to put, okay, let's solve it using units. So where there is m, I'm going to put the units for mass. Where there is L, I'm going to put the units for, where there is L, I'm going to put the units for length, which is the meter. Then here I'm going to put S to the power negative 2, because that is the period. These are the units. These are the units of force. So I am going to put my units of force, okay? But before that, if we introduce an equal sign, this becomes a constant. That becomes momentum raised to the power A. This becomes T raised to the power B. We can put our units for force. Because its dimension, so we won't put the constant K. We can put the units of momentum. What are the units of momentum? The units of momentum were kg msi. So it's going to be kg m s negative 1 to the power a. What are the units of time? It is simply s. Okay, S. Okay, that is going to be S to the power 1. Let's find the value of A and B. So we can find the value of A using the G's, of course. If we're using this guy, we're going to say kg to the power 1 is equal to, okay, so we only have 1 kg there, so it's kg to the power A. This becomes our formula 1. Okay. Then, of course, if we want to find for B, because B only has the S part, so we're going to say S to the power negative 2 is going to equal to S to the power B. This becomes our equation 2. So we can say kg to the power 1 is equal to kg to the power A. That and that cancels. Your A becomes equal to A, to 1. A is equal to 1. For this one, you can cancel these guys, and of course, you find that your B is going to equal to, this is going to equal to negative 2. Okay, negative 2, like that. Okay, that is going to equal to negative 2. So, when you reach there, you go on your equation. You go on your equation. You find that your force was equal to the momentum. Momentum is going to equal to the power. Okay, A is equal to the power 1 multiplied by the time B, which is going to equal to the power 2. Okay, so it's going to be T to the power negative 2. This formula can also be written as P over T to the power 2. That is how you come up with a relationship or a formula depicting the force relating with the momentum and the time. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much.